Welcome everyone. Today our channel. So I hope people know what we do. For who doesn't know, we're mostly focused on providing AI capabilities with drone and sensor data to solve problems in the energy industry. So today we start this podcast to share knowledge, talking with people around the globe. We are focusing on the APAC region. So we have a special guest, Mr. Vikram Bhatti. So welcome, Mr. Vikram.
Hello. Hi, everyone. And hi, Antano. Thank you so much for this podcast and inviting me to join and share my expertise in terms of asset management in the solar and onshore wind assets. Happy to join here.
It's a pleasure to people who will be watching. If you can share your experience, since you have more than 13 years working for a company well known in the market and the industry, from Total to Tata. So yeah, if you can just give us a brief context.
I would say I have completed my engineering back in 2012. And then from past 13 to 14 years, I'm working into the renewable sector. I started my career in the wind asset. I joined Suzlon Global Energy, and then I was responsible for maintaining the 100 megawatt asset. So I was like a maintenance in charge there, and then I spent there 3 years of time. Then I got a chance to work with Wind World India Limited, which is formerly known as Enercon GmbH. So I was assigned with the role of quality there. I spent 2 years of time there. Then I got chance to work with again German system inspection company, which is TÜV Nord GmbH. I spent there 2 years in the same quality role. Then I got chance to move to the solar side. So this was with wind, and then in the solar, I started working with Chint. I have done one ground mount project in Vietnam. It was having a capacity of 100 megawatt. And then I worked in TotalEnergies. So it's a French-based giant. So they have an idea of transition. So we were the first pioneer in the TSDG business. So which is a distributed generation business, basically, which is focusing on the C&I utility scale as well. And then we have this B2B business where we are giving the most affordable electricity to the customers. So by meaning that they have their own electricity, local electricity, and then they have a cheaper electricity from us. So we are doing the investment in terms of leasing their space, and then we install our system on their space, and we have a PPA agreement with them. Then we share the electricity, generate the electricity, we make them use the electricity, and then they utilize it. And then that was in the TotalEnergies. Then I got chance to work with Tata Power in India, and then the Tata Power is a big giant in India, as all knows. So we have different government schemes which Tata is backing it. Tata is producing the affordable electricity for the rooftop solar for most of the households, and then also the same with the C&I business as well, and then utility scale business. Right now, I'm working in the Verdant Energy as a operation excellence lead, and then I'm working as a main key person here to maintain all the operational assets and take due diligence, and then working as a stake person in terms of doing a bridge between the business management, project management, and the O&M team. So yeah, that's me. And back to you.
Great. No, thank you for this information. So I see a huge experience on the region itself. So as we know, I mean, APAC accounts for 60% of the global solar PV capacity so far, where we have India leading, at least led 2023 with 609 gigawatts. And after we have, I think, Japan, 91, and India. So why I'm talking about this? Because we see at least the ambition and the target. India set 500 gigawatts in terms of target of renewable energy by 2030,
Yeah.
which is 5 years from now, if I'm not
5 years
wrong.
from now.
So it's quite ambitious.
Yeah.
You have experience with the big players, which actually are participating effectively. So what do you see as the most critical and operational challenge in achieving this?
Yeah, as you rightly said, that there is a big ambition in the renewable side. So we already have this 280 megawatts built so far. And this coming 5 years, we will see the exponential growth of 220 megawatts to be added to complete our target, which is 500 megawatt. And that not only this, coming 2070, Indian government has set it a target to go net zero. Means all the generation should come from the renewable side, which is very prosperous target we're going to have in the upcoming years. And then there's a lot more in the operational and asset management portion to be explored and to be implemented in the present industry. So as I work with the giants, and then there is more focus in terms of what we are getting in the return of investment, like how the assets are performing. It matters a lot. And then we have a set it up the procedure where we have like day-to-day monitoring and then day-to-day diagnosis of the generation, like whether it is meeting our targets, it's not meeting our target, what's the gray area, what's the reason behind that. So we have utilized the market leaders to help us with this thing to do the analysis, to diagnose the case studies and the relationship between the generation versus the irradiation. So we always benchmark the KPIs based on what we have considered in the financial model, and with the help of that, we fix our budgets. And then by fixing that, we always look forward towards matching the targets. And then there is a lot of gaps in India and as well as in the Asianic countries where we don't have much consumption. As I said before, that this is more towards the personal private purchase agreement where the customer has to consume the full amount of electricity. But in order they can't able to consume by any mean of reason, we need to quantify that volume, and that's a potential profit for us. So we always chase that, and then we utilize this machine learning model where we see the generation from the past 6 to 7 days or 10 days sometimes, and then with the present irradiation reference, and sometime with the satellite data, which is backed by the solar GIS or Meteonom, we quantify the actual potential generation. And then we bucket it in the proper way where we can see that, okay, this generation belongs to maybe the curtailment portion, maybe the grid outage portion, maybe the planned outage, predictive maintenance, or maybe any other things. So on the basis of that, we decided like what is the wholesome generation.
Okay, so you're mentioning there is a gap from what right now from a PPA we expect to generate and what is the real consumption. What do you recommend? How do you think on a bigger picture? Because here we are talking about 500 gigawatts.
So basically, like first thing is that the correct assessment is very much important. If there is an asset we are going to sign, so we need to know the load variation. We need to know the load availability for at least 2 to 3 years. We should have that kind of a data in our hands so that we can access like how the load is behaving. So on the basis of that, our engineering team will correctly size the system. Then they will put a benchmark. Once that is done, then we have some sort of performance analysis while the project has been commissioned, and then there are lots of certain issues at site, like not only the design wise, it was basis of the environment around the system, like it's having a more soiling if it is close to the any highways, or if it is closer to the any factory which is having a huge soiling waste coming out from their exhaust vents. So is it sitting on top of our modules, or it is creating some sort of soiling loss, which is not considered in our design phase. So those things matters a lot. On the basis of that, we can benchmark it, and then we maintain the asset in such a way that it should not reduce from what it has been shown from the day one. So whatever the reduction is, it's our own loss. It's affecting our pocket. It is affecting our return of investment. So that's one thing we make sure during the operational phase.
You are suggesting to have, first of all, access to the data.
If it is not available, then we use the power analyzer. It's kind of a meter. We install it at the company grid connection point, and we see what is the generation trend there, like how much is their consumption, and then how much the load behaving for some certain period of time. So when it comes to the heavy haptic investment, so it makes very important for us to understand the load behave, how the load behaves. It always depends upon the capacity, like what capacity we are looking at and how much risk we are. So in case of utility projects, it makes very much important to do the technical due diligence, to do the red flag study. In the case of small scale projects, which is ranging somewhere 500 kilowatt to 1000 megawatt, we can depend or rely on the customer invoice bills, what he's getting from the local utility partner. So we can then have 1 year data. We can access that, like what's the load on the each month and then how it behaves.
I see. I saw something really interesting because you never work just in the solar space. We work in the wind as well segment. So I was curious, how has this shift shaped your approach to operational excellence?
Of course. So wind is something which excites me a lot, like because I started my career in the wind and I can see there is a lot of potential in the wind as well. Now, in the offshore side as well and onshore side as well. Now, in my present assignment, I also deals with the onshore wind right now. We are accessing the policies in Vietnam, in Philippines, to make it workable for us, whether it is happening or not. To build some sort of things, we required a lot of data in the wind compared to solar. Like in the wind, we have a wind mast installed, and that wind mast shows us that how much wind available in that particular region, and on the basis of that, we can design the plants. And then it requires some sort of like as we know that the wind asset requires 1 kilometer span at least from one to another. So it requires a lot of land to acquire and then make it happen. In the challenges in the O&M also it is there because there's a long distance from the base location and the location spreaded, in the hectares. So that we need to travel from one location to another location, which is again like a long process. So there are some quite challenges in the wind, but yeah, we have 24 hours, generation compared to solar. So it's makes sense.
Yeah, no, completely. I mean, for sure, there are two different in terms of investment. Can we say confidently that solar is
cheaper? It's cheaper.
I mean, let's say with new tariffs in terms of global affordability, but for sure there is quite clear trend in the reduction of this cost. So in terms of technology, I know we had discussion. I know you used previously in different organization, they have different infrastructure, different solution, even readiness, technological readiness, I would say, to approach problems in a different way. So what do you see or you have seen that you think right now India or players in this space could use on leverage? Do you think could be helpful to accelerate this transition?
So India is becoming a center of all of this. When I say this, I want to give one very good example. Like India is one of the company in India, which is Adani, and they are building a 30 gigawatt project in place Kutch, Gujarat, and which is like the area wise, it is similar to the Paris or maybe bigger than Paris, bigger than the area of Mumbai. And not only that, I have got chance to visit that location because TotalEnergies is a strategic partner with Adani's. TotalEnergies holds 51 stake in that project. So it makes TotalEnergies a major partner in that deal. And this 30 gigawatt project is going to be commissioned by 2030. Right now in China, we have 25 megawatt, which is a hydro project, which is the biggest project generating capacity project in all over the world. And then this will surpass that project in 2030.
It's great, especially if we think from an investor perspective, which I will say is my next discussion point. Because right now we discuss about macro trends, which is great to understand where we are heading in terms of direction from a national standpoint, but the overall as an industry and segment. Moving toward the financials, because at the end we know that without investment nothing could be possible. From an asset management perspective, what do you think makes solar projects in India right now compared to other parts of the world, as we know, particularly attractive to investor today? And what kind of trends or policy do you think amplify this appeal?
Okay, from the asset management point of view, you know that it's a very big area. Basically, when I say this, the life of the project, it's maximum like 6 months or 1 year. But the life of asset management, it's till the end of the asset. Like 20 years, it will stay with the asset management team. It includes the regular invoicing to the customer, and from the generation to invoicing of the customer. From the day one, we always look the gray area, like how we can increase our day-to-day generation values, and for that, what are the market available tools which we can utilize. Now, very popularly, there is a AI tools available in the market which can give us the predictive maintenance. There's also rain analyzer which I have utilized in my working past experience. So basically, I have prepared a tool which can predict that what is a soiling rate. So basically, having a soiling sensor, it's quite an expensive thing, and it's not maybe viable for small capacity projects. So in that case, like what I did is like I have prepared a calculator basically, and then this calculates the daily soiling on the basis of doing the average amperes for each of the string from the inverter, and then with respect to the irradiation, it tell us that how much soiling rate is being increased. So I took the meteorological data from each country like Vietnam, India, Thailand, China, and Australia, and I see that what's the rain trend. So if it is raining, I don't need the module cleaning hypothetically. So with the help of this tool, I just remove those days which is having a heavy rains. And then I just put a module cleaning on the months where it is required. So in that way, I can predict when the module cleaning is required. And then I can ask my O&M contractor to plan a scheduled cleaning so that I can have optimum performance. Since these things has to be planned properly, so this tools helps us a lot in terms of managing the asset. It's a one portion separately, like as I said before, there are lots of things happening in terms of the monitoring trends. Like now investors and our lenders, even though our board members wanted to see that how the asset is performing, what's the turnaround time to reduce the breakdowns and how fast we are acting towards the issues. So we always make sure that we record it in the system. So we are using this fixed CMS software, which is a computer aided maintenance monitoring system. So in that, like we have a ticketing system whenever we found any issues at site. So the performance manager, performance engineer, he raises a ticket basically, and then in that ticket he will put the description that okay, this inverter, this is a string, it is showing less values compared to others, please check. So the guy at site, he just got a message in his phone application. He opened the application, he go to the site, he scan the QR code. So there is a QR code pasted on all the devices. He scan the QR code, he got the access of all documents. He understand, okay, this is the issue, fix the problem, and then he again take a picture of it, and then he upload all the report, what his observation and what he has fixed, and then he resends back to the performance engineer. Then the guy closes call that okay, this has been rectified, and then this will be properly documented for next time. If the same issue occurs, at least he knows that okay, I fixed that on that moment of time, this time I should check for other things. So it's just an example hypothetically, like how we are using the technology right now in the maintaining our assets.
Yeah, no, it's interesting because everything at the end is really connected to technology, which I
Yeah.
think before perhaps wasn't really the case, but I see a nice correlation, which is, I mean, it's relevant to the nature of this discussion today. You mentioned several times reporting and the importance of CMMS, advanced maintenance tool
Mm.
for reporting and tracking. Yeah, from what we see even around the globe, there is still a gap between the technical aspects and, as we mentioned, the operational and the maintenance aspect of the
Mm.
projects and the financials. And even in terms of knowledge gap, which is completely reasonable, whoever is investing, normally asset management firm or private equity. So how do you think data can help in terms of transparency and or even operational efficiency? Because at the end, people care about numbers. And so what do you think can help? What kind of data can
Mm.
provide transparency,
Mm.
can help even for a good operational efficiency, and so basically
Very good.
boost this confidence? What do you think could allow the investor to feel more confident
Mm.
and know that, yeah, he's investing in something reliable, uh, and have that information quite quickly and effectively?
Yeah, absolutely. I think you're very right in terms of transparency. So I feel confidence. I feel confident more when I have a second set of data. So when I always do the analysis, I not only rely on the sensors available at site. When I say this, I mean that always I cross-check the data with the neighboring sites with the same sensor. I always cross tally the data with the satellite data available in the market. So right now, like we did this analysis where we have access of the solar GIS specifically, and then we have all the satellites, Meteonom and Solarcast as well. And then we have compared the sensor data, the actual site specific sensor data with the satellite data. We compared that and we found that there is a deviation of 4 to 5% only, which is very minimum. So we have, like, whenever it is required, we always have a second option to cross verify that what the generation numbers are being coming in my meters and what is the potential irradiation. So we take the actual site data. We know there can be a tampering, not always the case, but there can be a tampering on the sensor. Then they put a manual soil on it, and then the data quality is not so good. Or maybe there is some chance where the sensor is broken. Its connectivity is broken. It's not connected, well connected, because there is always a challenge of internet connectivity from the site. There is always the internet having an issue or the data missed for some sort of duration. So we compensate with the help of maybe the satellite data. If even that is not available, we'll try to figure out like what is the neighboring site within a 50-kilometer of radius. So we feel there is a less difference, and then we have some mathematical constant. So we multiplies that, and then we always equate that how much could be the available generation and what has been considered in the financial model. So when the investor standpoint, like they always wanted to look that we have invested considering this much of the generation year by year. So how far we are, or how we are matching or assuring that the generation is meeting the target or not. So we always assess that if there is a potential issue to the site, we try to mitigate it or try to eliminate the problems. Like if there is a sort of shading, or if there is kind of a new construction nearby which is creating a shades a lot, we try to remove those tables and we try to put it some new place so that we can have a good potential generation if it is possible. Yeah.
Okay, so if I understand, basically you're telling me there is still a gap from what people expect sometimes. Once we don't get to that performance generation, at the end will be the money generation, which is what is relevant for the investor. How to justify what's happening from an operational perspective, and how actually data can be actionable to show this trend and to show what is going wrong and why, and provide this, let's say, transparency by giving those data. I would say a component should be simplifying, as we said, because sometimes, someone who study accounting or finance, he really doesn't know that much about an inverter or a grid, right? Or all the components and the potential problems could affect the performance of the asset itself once it start becoming really technical. So I think technology in that sense, what we are trying to do at ClearSpot, will it simplifying the information? Because at the end, we know that what is really essential can be simplified. The thing is, there is a lot of noise coming from all these sensor, from the performance itself. So I think technology can even help in reducing, filtering all the noise to provide a clean report, which can become actionable, which at the end is what we are talking here is things go fast. We know from a replacement, maintenance, operational perspective, the objective will be everyone should be able in a single moment in time to take the best decision, assuming that yes, the highest context of what is the problem. I think giving that kind of level of context when sometimes there is this knowledge gap, which comes, which is natural from a background, different types of background, I think could help. So makes sense. What in terms of concerns? I think there are, I would say there are some most common concerns that investors can have about those projects. And if we focus specifically about India, how do you see in your experience, how can operational excellence really address those and this and to the risk, actually, the investment?
Of course. So in India, like the major concern is with the turnaround time, I would say. So whenever there is an occurrence of breakdown or whenever there is an occurrence of any issue at site, the main problem is to access the site and to resolve the problems, you know. So there is a key parameter here that the selection of the contractor or subcontracting few of the tasks. So selection procedure, it's like we need to have a subsequent, you know, the O&M scoring sheet, like where we can score the vendors on the basis of the value addition, on the basis of the team structure, HSC policies, or method of statement, or maybe like the tool stackers they have, the vehicles they have. So on the basis of that, we can score them before selecting them, and we need to be very careful in terms of that. Like the person has to be very much confident and well trained or well certified. Like he should have the work at height certificate, he should have the electrical competency license. So in India, basically, there is a standard being followed right now in the market that only the competent person is allowed to go at site, and there is a buddy pair. Like always, you should be with someone along with you, and then you can accomplish the task. You should not be alone at site to avoid any, if there is any sort of accident happen, then at least the other guy can support you and fix the issues. So something like that, like we see this kind of a challenge in India. Also, India is a big market. So from north to south, the weather changes a lot, the terrain changes a lot, and the nature of problems also changes a lot. Like I am sitting in Rajasthan right now. Here, the temperature is 45 degree, 42 degree, where so where like you can see different challenges. And then when you're working in the southern part of India, you have more rainfalls there. So you will feel more insulation related faults there. So it becomes very hectic, you know, in terms of managing the same contractor for the locations which is having a different locality, or its geographical location is changed. So we need to be more, more inspection we need to do there, or we need to be more careful in selection of the contractors. Yeah.
Okay, so basically you're saying there are some constraints, which I think that are common everywhere from a legal policy perspective. Still, we need to do our due diligence for whoever is going to invest, due diligence to make sure all the shareholders are aligned. Now, if we move toward, which I think is what seems to be really relevant moving forward from all this point of view, from a monitoring and reporting perspective. So we talk a lot about data, but we know that not all of data can be available, which can be comes from actually the availability of the hardware itself. the investment. We work with drones at ClearSpot, so we know that there are a lot of technology which can be used, but this technology takes a time to get to the maturity where we can be confident in seeing this hardware available. I think, but at the same time, there is even an investment that needs to be made, which we know that can be challenging for some people, especially small providers. So right now, focusing on drones, we know they have huge, especially on the thermal identification of hotspot diodes, which is playing a vital role in speeding up the process of inspection, monitoring. I know they have been used during an special installation, make sure that all the panels are aligned. So, and after we have the component about the sensor, irradiance sensor, a lot of sensor actually, it can be really expensive, but it can provide really granularity in terms of data, and can be correlated with a lot of information, as we mentioned, geospatial data with more, if they are connected, then I repeat, another point is availability of the data and the quality could be correlated. So right now, how do you see the role of this advancement, like drones, sensor, in the operation and the maintenance scope?
Yeah, no, it's very much important to have a drone analysis. I would tell you a specific case. So just recently, I have visited one of the asset which is we are going to purchase, and then we did this thermal drone checking of the asset, and we found that one string having a lots of hotspot on the top of the module, and then we have further investigated like what is the reason of this kind of a hotspot. And you'll be amazed to know that like this was a pattern in 6 to 7 assets in a row. And the reason being of getting this hotspot is basically a dirt deposition over the module edges. So when you have a lower tilt angle of the module, like most of the assets, which is like in the Asianic country that's near to the equator. So we have a lower tilt angle basically compared to the north assets or south assets. So in that case, like the dirt get deposited when there is a rain or when there is a drizzling. So all the dirt from the module, it wiped out and then it deposited on the edges of the module. And then water will get evaporated eventually, but the dirt still remains. So that can only be removed through the manual intervention or manual module cleaning activities. Or else we can put some sort of drain clip, which is widely available in the market because of this problem. So that is like creating this hotspot, and without a naked eye, you can't able to know that whether which module panel is getting hot or what is happening.
I mean, you have the gun, you have the thermal, I will say gun, but yeah, maybe it's not the same.
Yeah, we actually had this drone and then gun as well. So from the drone, we identify, okay, which table is having an issue. From the gun, we can specifically check whether which cell it's having a problem. So like after that, we can touch the cell and we can understand, okay, it's really hot. So yeah, that's pretty much important, like to have a drone inspection, thermal drone inspection for the asset. And yeah, it's recommended. Like we can do that because sometimes we don't understand like why there is no generation, why we are not meeting the targets, whether all the sensor, everything is working fine, my modules are working fine, my inverters are working fine, still I'm not meeting the target. Then in that case, like we can fly the drone and we understand, okay, we have the hottest spot in, and that's the reason why we are not attaining the target. So yeah, that's one thing.
I think it's, it's clear that especially when there is a lot of stress, especially coming from the operational, the maintenance, and after the pressure from investor in asking question, and despite the challenge or the efforts, when unfortunately when you cannot monitor, you cannot track, you cannot analyze, you cannot provide answer, and you cannot really know and be confident in saying this is why. So makes sense. It's great that you have this experience, because I mean we see that still in terms of adoption, a lot can happen, but for sure happens with the, first of all, the legal side and the policy. You know, in India, for instance, it's been banned, one of the most common drones worldwide, because they have their own trajectory and ambition in the being manufacturers and deploying them. For sure, they're doing a great job in the agricultural space. with pesticide. But yeah, so staying on the point, for sure, by deploying this technology, there is huge time and performance saving. What do you think, since we are talking about new tools, so new tools can provide more specific and granular knowledge, how do you see this integration of, from a sensor, from perspective, from a data collection standpoint, how do you think those data could be integrated in your system?
So basically, sensor plays the significant role, and we divide it in a way that based on the capacity what we have. So like let's range from 0 to 400 kilowatt, we install one sensor. From 400 to 1 megawatt, we install two sort of sensor to compare the data of different terrains. So basically, always the landscape is not usual. It's always have a wavy kind of a land. It always have a different kind of a slopes in the land. So the installation always majorly adapt to the landscape. We tried to cut the land and we tried to backfill it to make it more plains, but that's not always the case. Like we have to attain what is the trajectory of the land. So on the basis of that, we install the our system. Sometimes like we try to utilize as maximum as possible of the land. We also have this the tracker system where it follows the sun trajectory and it try to capture as much as possible irradiation. So it happens more to those sites which is far from the equator, like if we talks about northern part of India. So we have more tracker kind of a system. So we have a table where we have installed 24 to 30 modules in a table, and then we have this motorized gearbox system which can like have the radiation connected with, and it follows the track of sun. So we can have a more production in the end of the day. So that's also excites the investor, and to see like with the same efforts how more revenue we are getting it. And then it increase the challenge in O&M, because we need to maintain the tracker, we need to maintain the sensor, we need to maintain the generation throughout, and we need to ensure that there is no maintenance challenge or there is no breakdown in the system. So we make the method of a statement for that, and then we properly finds a contractor who can deal with these kind of things. So yeah, that's also most popular right now in India as well. Like we have more tracking system in place.
Yeah, no, I see. So it takes more effort for you in order to maintain those systems,
Yeah.
but at the same time, you can deliver better, more insights, and definitely, and finally, better performance.
Yeah.
It's great. I mean, I see, makes sense. On the quality assurance of which is central, especially in your expertise from your profile. So what do you say in terms of those sensors? How do you think sensors, and for sensor, I mean, even drone application, will streamline those on-site audits, and even sometimes supplier evaluation, because we know things change quickly, things needs to be replaced. And sometimes you even toward those suppliers, you need to approve of this, something is broken. Why? What is the reason? How do you think this technology can be used, it can be leveraged in order to make sure that we can guarantee higher standards at the end, finally?
Of course. So basically, as I mentioned before, that we use the CMMS tool to track what is the next calibration of the sensor. So the sensors always having issue in terms of the quality of data, like how one can ensure that the quality of data is adequate or whether the sensor is working fine. So there is only one way to identify that, the periodic testing of the sensor, or maybe we can have adjacent sensors, like we have a pair of two sensors, so we can at least see like, okay, this sensor speaks this much, this sensor speaks this much, so they both are relevant, having a relevant data. We have a lab in India where we can, it's a NABL accredited lab, and then we send the sensors there. They have a room where they can like do this check of irradiation, and they can fine tune it, like what is a deviation or what is the delta between the actual sensor versus the sensor we are utilizing it. We have the lab in Singapore as well, and we have a lab in I guess in Vietnam as well now. So few countries like where we don't have the labs, we take the sensor out and we send it there, and then we have a replacement sensor available at site which delivers the data for the time being. So it plays a crucial role because everything, all the estimates and every performance analysis is based on the sensor data, like what we are getting from the site. Now, most of the time, like I'm seeing that most of the investors are relying on the satellite data rather having a physical sensor at site. The reason being is that there is required a maintenance to the sensor, and there is a quality issue of the data, like whether the data is correct or not. So that's one major concern for the investors, like whether if they are cleaning the site, are they cleaning the sensors as well at the same time or not? So we now like utilizing the CCTV, which is installed at site, and we see actual maintenance happening to the site. So we can cross-validate that part, but it's not so much, 100% being followed. Like not anybody looking at site 100% on the CCTV. So always like there is a uh, confusion whether the sensor is clean at site or it's not clean. So yeah.
Yeah, no, I see. I mean, so far as I think we coming back to the previous point, which
Hmm.
more sensor require more efforts, attention,
Yeah,
can
sure.
provide more granular knowledge to
Exactly.
correlate with specific problems, but it requires more at the end, even investment, which
Yeah.
sometimes we need to maintain those. I think, as you mentioned, it's a huge. I think I don't think the importance is stressed enough.
Hmm.
When we talk about maintenance,
Hmm.
and yeah, once we should pay more attention in that segment and making sure
Hmm.
that if the data are available, at least we can use them. And as you
Hmm.
mentioned, some people are using even geographical data, spatial data, which cannot be data accurate. When we talk about, we need really specific answer. Sometimes why we push for drones, because drones can get even to granular. With LiDAR sensor, we can get to
Hmm.
millimeter dimension. So we're
Hmm.
actually, if it's a crack, and after we use even thermal cameras and we define an hotspot, we can really correlate
Hmm.
with what you mentioned. If you have sensor on site, with those sensor data, we can come from the
Hmm.
inverter itself, or even from geospatial and weather data. I mean, there are a lot of correlation can happen. We're focusing on this. We are trying what we are trying to change compared to what people are doing, and I think it's still correlated to previous, which the lack of tools which were not available, but right now they are. It's
Hmm.
really we can empower, and what we do, it's empower the drone itself to on-site to define specific anomalies rather than still relying on the post processing, which is still good because sometimes people are getting those image and
Yeah.
analyzing, and they can give an insight to the investor or at the maintenance or operations. But my point is, it's important to rely on this technology, but we need to do it right. If we do it, we see a lot of people from that acquisition to the analysis where actually have challenge because it's something new. I think no one with electrical background, engineering background has been trained on ML, AI, and we're talking about a huge volume of data. It's like
Hmm.
I think it's another component. We talk about a lot huge volume of data analysis.
Hmm.
So I see a lot of people investing in this trajectory. They try to understand and learn more about the AI and how this model, even we see with DeepSeek, could deliver even on edge. So without sharing those data.
Yeah.
So I think it's clear. It's great that it's quite evident this investment and the trajectory. So let's go on the operational excellence side and on the trends we can
Yeah.
just before we close. So
Yeah.
since I think your previous experience was quite strong on the maintenance, you mentioned some maintained plant availability above
Yeah.
98%. So what kind of strategies will you recommend? Or we mentioned about technologies,
Yeah.
but what you manage to get to 90% of availability. What do
Exactly.
you could recommend, or even the most problem and common problems
Yeah.
you face, and what you feel like sharing with our audience about best practice, even
Yeah.
framework if you have any. I mean, I think will be really
Hmm.
helpful.
Hmm. So basically, when we say 98% availability, so it's a system availability. So that directly means that how quick your response is. Like what means to say is like there are total operating hours in the inverter, like how much your inverter has operated versus how much your inverter ideally operates. So to understand that how much your inverter ideally operates, very easy. We know the operational hours in a day, and then we multiplies that with the inverter, and then we get that value. And then how much actually it worked, this also logs in the inverter. So we take that log and we compare that versus this, and we understand like how much percentage of this. Now, we frame the contract and we educate the subcontract company like how we need to operate our system, like what's the turnaround time, what's your physical availability at site, like how fast you can reach to the site, how fast you can respond to the fault. Now, not only this, it also involves the predictive and preventive maintenance. It's very important for us to do a proper maintenance. So we have this proper scope of work, what they need to do at site, and how they can ensure that the cables are good, the terminations are good, and the electrical components, devices are perfectly fine. There should not be any sort of deviation in terms of doing the regular maintenance job. And everything should be well documented, and it should be audited by our in-house team, like whether they are following the required essential things to be done or not. So it's a kind of a surprise visit for them, where one of our teammate, we give sort of things like, okay, we are doing this maintenance of these many assets. So maybe someone from the finance, someone from might be from the communications, marketing, or legal randomly go to the site, and he just do this kind of surprise visit where he ensures that, okay, fine, this is being done or not. So this is a management call as well, that what they want, like in terms of operation and maintenance. So we need some sort of that support and guidance from the top management. Like, okay, we need to do some sort of surprise visit, at least 2 visits from each of the department, and that should be in their KPI. So if that is there in their KPI, there will be a culture of having a good operational asset, you know. So that's really important. And then we, on the technical side, like we ensure that all the device has been tested well. We do the IV curve testing. We do this the insulation resistance test as well. We do the different component tests to ensure that their healthiness, and we store that data in the lifetime file, where we anytime, like if you want to take the reference, like if there is any failure occur, we can just recall the files from the last inspection, and we cross check whether what has been done in that time and what was the failure time in between this. So we keep the space up. We also maintain the space, like we maintain 2% or 3% based on the site requirement, the space always in the warehouse. So if there is any issue, we just replace the spare, and then we later do the investigation. That's part of maintenance. Yeah. So by that, we maintains the higher availability.
I think if you can resume in 3 letters, PP. So outside of the technology, we mentioned process, where action needs to be in place in order to make sure that, because I mean, the technology by itself cannot really fix problems. It's just an additional support. People, because I mean, at the end, people from different departments needs to be involved and committed, and we're not just being randomly, but consistently. Because I mean, 90% of plant availability is really it's impressive, and I think it's something where people sometimes, rather than relying too much on tools, should rely more on people, right? Which at the end finally are ultimately accountable for this performance. Absolutely. And the third is paper, like keep the paper, the process, all records of, and track to monitor, and after I repeat, which is the final stage in our space, analyze and provide insights. Without all these things, I think technology can really help, cannot really enhance the productivity of people. Great. So we talk about the data, we talk about the process, we talk about the people. Now, the next stage is, which is what we do, I mean, is what we are trying to focus on. And I think there is a huge worldwide attention on. We know about this trend of sustainability. The question now will be how AI, how do you envision the integration of AI? We mentioned about drones, we mentioned about sensor data, transforming those the solar project management in India, at least over the next decade. Why I'm mentioning, I think it's really interesting in India because there is, in terms of hub of AI, robotics hub, and we can talk about robotic cleaning for the cleaning aspect, or we can talk about sensor data integration from manufacturers. We can talk about drones and delivering those kind of high capability from sensor, thermal, LiDAR for accuracy and relevancy of data on site. So how do you see that? What kind of trend you think excites you the most as well, maybe?
I would say involvement of AI is really crazy. Like I'm surprised to see what takes me hours and hours, it's now happening in the minutes. When it comes to be in the analysis part, like I need to download the string data, I need to download the inverter data, and then I have to manually transform in the Excel sheet to get the relevant result. And now it's happening like really quick. It's like automatically the system is getting connectors of AI, and then all the data is being transferred to the AI directly, and then they analyze and they actually give us that, okay, this portion, this is string, this inverter is having issue. So we just have to focus on the resolution. We don't need to spend our time in doing the analysis, you know. So that's like a very quick information, and then this helps us to maintain the asset more efficiently. So I would say like this is the expansion right now what we had, and I've seen like lots of tools available in the market. Like there is a machine learning model based on the Python language. We can have it. So yeah, it's really nice to see this kind of, and it excites me a lot. Like what is the next now? Always.
Completely. I think the first point, as we said, is that we talk about AI. I think people sometimes they forget it's at the end we can provide and have the support to process information, but the first point, and I think is the most important from what you mentioned, I think it's the storyline is quite accurate, is to make sure that the process, the people in place can allow you to have the right data, because without data and without high quality data and reliability and access, you cannot really train any model. And at the end, we know even the challenge sometimes to get access to those. I think sometimes manufacturers or utilities company, they know about the value of the data they have, but if we talk about smaller site, they are not exposed to this volume. They don't know how, and for those models, we are talking about really huge optimization in terms of performance, which can really be helpful. And so we are trying to provide even more access to this kind of data to the all public, which at the end can profit. We're about profit, which can really translate in benefits from a financial perspective, not just nice. This, I think, is one of huge impact. And for sure, after the second point is we analyze insights and decision making and act. I think where the agentic is moving, and I will say will be correlated to the even hardware, and we'll get on the robotic side of the things. Moving forward from the cleaning, from the evaluation, the side, in my vision, you will have the human will oversee the machine in validating what the machine has detected, because I think the ultimate technical eye of someone validating, even if that is a problem or not, can be helpful. And ideally, closing the loop, the automation loop with from the cleaning to even the monitor itself with drones automated for the inspection, the monitoring, cleaning robot to make sure that the panel are efficient enough, as you mentioned. So yeah, I think moving forward, we can save a lot of time and ideally for investor a lot of money from those assets, because we are talking about in India 300 gigawatts. If we get to those numbers, we are talking about huge performance. 1% on 1 gigawatts can be millions, and we have seen that can be represent millions. Here we're talking about hundreds of millions of losses. Just by no monitoring, which I would think is the first point. It's you start monitoring, and after you can optimize, analyze. But you need to start monitoring, and to monitor, you need to have access to those things. So last thing, so in terms of right now, Director, Head of Operational Excellence at Verdant, what tomorrow, ideally, what do you expect to see? What are kind of bold innovation? Now we talk about innovation based on what is available, what could be available even in the future, in the commercial segment. What is one bold innovation you like to see eventually implemented in the next years in the solar industry to drive this, what we mentioned, this efficiency and scalability?
Yeah, so I would say that is happening right now. First thing is like the market, it's really tends towards the decentralized kind of a system. Like if you have a centralized system at one place, your risk is on the higher side. Maybe like if your let's say your transmission network has a fault or your delivery point has some fault, your whole system will be collapsed. So now, even in India, I have seen lots of things happening towards having a decentralized kind of system, like to provide a captive power plant to the industry or to the households, so that they can enjoy the electricity by their own and they can be independent working. So I've in the word in energy as well, like I've seen this the more focus in towards like empowering the industries and making them independent from the at affordable price. So that's very nice and that's very prosperous goal. Also, there is an integration. What I have seen in Verdant Energy, like there is an integration of all the different teams. I would say like there are teams in the business management, there are teams in the finance, there are teams in the operation, project management. So there is integration with the help of building a CRM tool. So which makes like all the stakeholders in one place, and then the information should be very quick, like what is happening if there is a new business lead, what are the requirements, what has to be done by the different teams, and has to be close as because it's a very competitive market, as you know. So that's one implementation I have seen. In the technology wise, I've seen there is lots more involvement in terms of the maintenance, the use of high-tech tools, including the drone as well. Like we have proposed that we need 2 drones per region so that we can do this kind of a thermal inspection of all the assets. And then I've also seen that there is lots of advanced tools which is utilized to see the trend of the generation with respect to irradiation. We also have this zero export devices installed since the energy cannot export toward the grid. So this device allows us to limit the inverter and optimally like it able to generate the electricity as per the consumption. Now we also have this high voltage right through and low voltage right through, like HVRT, LVRT, enabling in the inverter, so that in the case when the grid is not so stable or if it is having a very high voltage or low voltage, at least at some certain of point the inverter should run. So these kind of advancement I've seen in the technology wise, and yeah, we are progressing in that. Like even though this machine learning and AI tools are now helping us towards like what is the mean time between failure to identify and to predict the maintenance jobs. So yeah, that's something.
Great. I mean, I think it's clear right now the impact of those innovation those can have. I mean, concretely for the whole ecosystem, from the maintenance, operation, the finance. So right now, just to close, based on your experience, extensive experience, we talk more about 10, 13 years almost of experience working with those players. We mentioned Total, Tata.
Yeah.
What if you could choose one piece of advice you think you could give to a renewable energy professional or investor, which actually might be looking to capitalize on this Indian solar?
Yes. Yeah, I think I have lots of advice to make, but if I can conclude on one.
Just one.
Yeah. So
Big thing.
Yeah. So the big thing is like look from holistic view. Look the asset from holistic view. I mean, when I say this, like you don't look at the project as today's baby. You have to look it for 20, you have to stay with it for 20 years. So do like first thing right thing. Like that's what I want to say. And then look at from the perspective of a person that you have to run and you have to take as max as possible from that asset. So that's my one advice.
Yeah, no, it's great. Thank you. I mean, I think it seems completely reasonable. It's aligning with what we are doing. Like we try to give an holistic view because I mean, we can give you, how we said, everything requires an investment. So I think your
Yeah,
perspective on shifting your mindset from right now, because an investment at the end, you need to even, dilute that investment toward 10 years, which is what is an PPA at the end.
absolutely.
From an investment perspective, the point will be, how can you even justify those investments? When we talk about, I need to invest for those kind of sensor, I need to invest in those kinds of drones, I need to invest for software, I need to invest in processing. So I think this perspective can be really useful once you put things, and analytic at the end finally is like what we do.
Yeah.
We see, we hear, and this when it's more complex, the infrastructure makes sense that you have more support to make sure that make any choice it's right. So I think, Vikram, anything else you would like to add? I mean, it's been great. Thank you for sharing your knowledge. I think
Thank you
it's been
so much.
really efficient and helpful. We have been helpful for other people. We might have other series episodes, perhaps focusing on other part of the world, because we like to give, voice to each individual player around the globe, rather than just focusing on one specific nation. So yeah, thank you so
I'm
much,
glad to connect with
Vikram.
you. Thank you so much. And thank you so much. You're doing very good thing,
Thank you. It's a pleasure.
Bye-bye. See you.
Thank you.